Hello, everybody, and welcome to this talk. Thank you very much for tuning in. I'm very glad you decided to watch this. So my name is Steve, and I work at Microsoft, mostly focusing on web-related things. I'm also on the .NET team, so this subject is very interesting to me. And to set expectations, what this talk is about is some experimental ideas that we're brewing up about where we might go with .NET on WebAssembly in the future. Now, you've probably heard of Blazor WebAssembly, which is a way of running a UI framework with .NET inside a browser on WebAssembly. But that's not what this talk is about at all. This talk is about the potential for using WebAssembly on the server. Now, to understand why that is useful and what that really means, we need to take a little bit of a step back to understand, firstly, what WebAssembly actually is, and then what WASI is. So let's start with WebAssembly. What is WebAssembly? Well, it's a bytecode format, a way of representing instructions that are independent of any particular machine architecture. And the intention is to run them in a sandbox. Now, of course, it was originally designed for running in a browser where you may have potentially hostile code. So it's a very rigorous sandbox indeed. And in fact, the only thing that WebAssembly bytecode can do by default is just perform operations on its own memory. So that's all it can do, is just change numbers in its own memory space, which would be kind of pointless if there was no way of interacting with the outside world, which is why it also has this concept of importing and exporting functions. So the host that's running the WebAssembly code can supply some functions into your WebAssembly code that you can call, and similarly, your WebAssembly code can export some functions that the host can call. So that's what WebAssembly is, which has mainly been used on browsers in the past. But there are many people who are saying that this could be a major step forwards if we start using it on servers as well. And if we wanted to use it server-side, we would need to have access to some operating system functionality. And the only way we can do that is if there are some function imports that represent it. And what should those function imports be? Well, that brings us to this concept of WASI, WebAssembly System Interface, which is a spec that's been around for a few years now. And what this defines is a standard set of system imports that should be provided to WebAssembly code that allow it to do things like accessing a file system or accessing network sockets or other functionality that you would get from an operating system. But despite this, it's still very much sandboxed. So just because there are some file system APIs doesn't mean that your module is allowed to use them. The host chooses which functionality to opt into giving you. If it doesn't want you to access the network, then it won't give you the socket imports, and then you obviously can't access the network. So it's still very much sandboxed. And like I said, this is not about running in a browser or in any kind of JavaScript environment. The idea is to run in potentially a very, very lightweight way with very little other functionality available. It's just a pure system for running code with a particular set of OS functionality. Okay, so that's a bit abstract. Let's start thinking about why you would actually want to do this, because obviously you can already run code on your server. Why would you want your code to be running inside a Wasm sandbox and using WASI? Well, this one way of thinking about this is that it's a universal application binary interface. Okay, so what that means is it's a mechanism for a host and application code to interoperate with each other. Now, that host could be some kind of cloud-based service. It could be something running on the edge of the cloud, like in a CDN or in a low-powered Internet of Things device. Or it could be a plugin model for an application. For example, an Office plugin or a flight simulator plugin or plugin for some sort of industrial software. Or maybe it's some programmable feature of an operating system. And then the application code is, of course, just whatever code you, the developer, want to write. And the benefits of having WASI representing the ABI between these two things are substantial. There are benefits on both sides of the equation. For example, on the host side, it means that the code that is being run is fully sandboxed. Now, that is, of course, useful if the code turns out to be malicious, but that's not very common. A more common case is that the code is trying to be good, but it contains some sort of security vulnerability. And the sandbox is going to protect the host from that. It also means that the host gets to choose which functionality it wants to make available to each of the modules that it runs. For example, should it have access to the file system? Should it have access to the network, and so on? But it can even go further and impose constraints on things like how many CPU instructions a given call is allowed to take, how much memory it's allowed to allocate. So the host gets very strict control over what this application code is going to be able to do and how much of its resources it can take up. It also means that the people building the host don't need to create another custom build toolchain just for that host, because in fact, they can just let you deploy any single Wasm file that you've created using any technology that can do that. And then on the application side of this equation, the benefits include that you can use any programming language at all, as long as it compiles to WebAssembly, which is most of them these days. And then when it comes to deploying, you don't need to care what kind of operating system you're deploying to, because the same Wasm binary will work on any operating system and even on any CPU architecture. You just don't need to know whether it's an x64 or an ARM machine or something else. Doesn't matter, the same binary is going to work. And of course, by the nature of WebAssembly and the way it's been designed from the very beginning, your code should be able to run at near native speed in this kind of environment. Okay, so there's lots of potential advantages to this sort of thing. So can we potentially run .NET in this sort of environment? Well, you might be thinking that, yes, because we've already got Blazor WebAssembly that proves that we can compile .NET and run it in a WebAssembly environment, so we're done and we can all just go home. But unfortunately, that's not quite the case. It's a bit more complicated than that. The way that we build a Blazor WebAssembly application is no good for running in a WASI environment, unfortunately. And let me just explain why. Okay, so when we build a Blazor WebAssembly application, we're doing so with a toolchain called Emscripten, which is a fairly old thing. It goes back to the beginning of WebAssembly, and it's designed around building things so that they can run inside a browser. Okay, so when you build a Blazor WebAssembly application, what comes out of the build process is the .NET runtime compiled to WebAssembly. So that's a file that we've already built for you, .NET.wasm, and everyone is sharing that same binary. And then, of course, your build output includes all of your .NET DLLs for your application and any other packages and system libraries that you're using. And finally, it includes a bit of JavaScript wrapper code that knows how to start this stuff up in a browser. And then when your code is running, when you use any operating system functionality, for example, you make a network request, then that ends up being a call into the JavaScript runtime. So this all makes sense in a browser, and it's a good system for a browser. It's good that we split things up into lots of files because it means the download can be parallelized. And it's good that we're making use of the JavaScript runtime because, of course, that's what's there inside a browser. But this is no good if you want to run on a WASI runner. For two main reasons. One, it's really bad that there are so many files because that's very inconvenient to deploy. And sometimes it's even impossible because some runners will only let you have a single file. And it's also kind of a problem that it relies on JavaScript because there is no JavaScript in general in a normal WASI environment. So it's obviously just not going to work, which is why we've started investigating a different way of building a .NET application to WebAssembly using something called the WASI SDK. Now, that is an SDK built on the LLVM toolchain, which is a pretty industry standard thing. And when you build using this SDK, what comes out of it is just a single file, your app.wasm. And that Wasm file contains everything needed to run your application. So it's got your code, it's got all the parts of the .NET runtime we need, and any other supporting files that you're using. And when you try to use OS functionality, it's not going to use JavaScript calls. There is no JavaScript. It's going to use the system interface functions that are provided by WASI. And so you can run in any WASI environment. Okay, so let's have a go at doing this, shall we? And I'll need to caution you that what I'm going to show you is just an experiment, okay? We're not committed to shipping any specific product in this area yet, but we do think it's an area that's very interesting. We don't know that WASI is going to become a big thing in the industry, but what we do want is to make sure that wherever the industry goes, .NET is going there as well. And you as a .NET developer will find that your code and your skills are extremely relevant and you can be a first-class innovator in this new space or wherever the industry does go. All right, so let me show you how this could work. So I'm going to start by creating the simplest thing I can, which is going to be a new console project, and I'll call it Hello WASI. All right. So that's not, of course, that's just a normal .NET Core application. It's not WASI yet, but we'll get to that in a minute. So let's go into there, and I can .NET run that, and it's just going to print out hello world or whatever it does by default. Okay. So let's just make it say something slightly more interesting, not a lot more interesting, but that's not what I want. I want this URL from in here. Okay, I want that stuff. Right, so I am going to make it say what the current time is and which operating system architecture we're running on. And if I do a .NET build on that, and then of course I can do .NET run, we should see it now says this is what the time is, and you're running on an x64 processor. So this does not involve any WebAssembly just yet. But let's say we want to compile this to a Wasm module. Okay, so to do that, I'm going to add this new experimental SDK called WASI-SDK, which is on NuGet now. You can try it out yourself if you want to. And now I've added that, and the next time I build, something slightly different is going to happen. Okay, so firstly, it is going to produce the normal .NET DLL that you would normally expect to generate, but that won't actually be used at runtime. So we can just ignore that or even delete it completely if we want to. And then you'll see it's also busy bundling all these dependencies that we've got to produce a Wasm module. Now, it does take a moment the first time we run it, but it should be nice and fast if we do it again, because it doesn't have to repeat any of those steps. So if I run it again, here we go. We've got our Wasm module nice and quick. Okay, so it's just this single file that we need in order to run. So how can we run something like this? Well, there are various different WebAssembly runners that can run server-side or in a command prompt. And I'm going to start by using one called Wasmtime. Now, Wasmtime is built by the Bytecode Alliance, which is a group of companies that includes Microsoft. This one is special to us. And if I run Wasmtime and give it a reference to my Wasm module, you'll see immediately it runs and it produces exactly the same kind of output as before, except now we're not running on x64, we are running on Wasm. And this is, in fact, a fully WASI-compliant module. Now, to clarify what that means, let me show you. So if I use this tool called Wasm objdump, I'm going to tell it, tell me a list of all the imports that we're using. So what functions do we require from the host environment in order to execute? And you can see that we're using 23 imports. And it's all things to do with file system access and clock and things like that. Now, you don't have to worry about reading and understanding that. All you need to notice is that every single one of these is part of the WASI snapshot preview 1 namespace, which means it's a WASI standard function. And we don't rely on anything that isn't a WASI standard. Therefore, it's a fully WASI compliant file and it should run anywhere. For example, I can use this other Wasm runtime called Wasma, which is made by a different third party. And if I pass my module to that, then it's going to run and work in exactly the same way. All right. Cool. So we can build a .NET console project and produce a standalone Wasm file that will work in a WASI environment. Great. But the whole point of doing this sort of thing really is to take us into a modern world of cloud native architecture where we can run WASI usually for something like building network services and not console applications. So if you want to build a network service and you're a .NET developer, you probably would want to use something like ASP.NET Core. But can we do that? Can we take something as complex and large as ASP.NET Core and compile that down to a standalone Wasm file that runs inside a WASI runtime? Well, let me show you. I've got over here a very simple ASP.NET Core application. It's just about the simplest thing I can do. It just responds with this string hello and tells you what architecture it's running on. And it's completely standard except for this, use WASI connection listener. And what that does is it tells us that instead of using the normal Windows or Linux networking APIs, that we want to use the network APIs that are provided by WASI. And if you're wondering where that comes from, well, it comes from this package, which I've added here, WASI ASP.NET Core Server Native. And also, I've referenced the WASI SDK because, of course, I want this to compile to a WebAssembly file. I also have to specify a few parameters for the runner so that it knows what port to listen on. Now, this is set up so that I can just .NET run it, or F5 or Control F5. So I'm going to Control F5 this now. And when I do, we should see that it pops up inside the browser, and it does indeed return our message that we expected. And if we look at which native binary is running here, you'll see the native binary is actually Wasmtime. So that is how it is running. But other than that, it looks and feels like a normal ASP.NET Core application. Okay, so that works, but it's kind of boring. It's still just the web equivalent of logging hello world to a console. Can we use some of the more advanced features of ASP.NET Core? So I would like to explore that a little bit by switching over to a different application. So here I've got something called ASP.NET Core Features. And if we look in there, you'll see it's pretty much the same thing that we just get by default when we create a new project with the ASP.NET Core project template, except I've also added a few more things into it. And I'm going to start that up now, and that should work just the same as before, except now we're looking at a lot more stuff. So what we're looking at here is an MVC controller, which is rendering a Razor view. We can also go in here and we've got a Razor page. We've got static assets. What else have we got? We've got minimal APIs. For example, here's a simple API that just displays the current time. And if you want to see the sources for that, well, that would be here. So it is indeed a very minimal API indeed. We've also got some slightly more advanced things, like we've got gRPC here. This is the classic gRPC demo scenario that everyone starts with, where you just say hello to whoever makes a gRPC call. To prove that that really works, I've also got this console project here called greeterClient, which is going to make a gRPC call to the server. And so when that starts up, it should invoke the server. And I changed the port that I'm running on. So let me just change that quickly, and then you will see that really work. So that's the real port that it needs to be on. So if I do that again, just proves that it wasn't a fake demo, and it really does hit the server there and get that response back from ASP.NET Core running on WASI. All right, so we've got gRPC running there. What else have we got? Well, we've got SignalR and WebSockets. So I don't know if you've seen that these could work on WASI before, but here we go. If we go in there, we've got some perfectly normal SignalR code, and this is the classic SignalR chat example. And the normal way to demo that is to have two windows, and we'll say hello from WASI. And when I hit send on that, you'll see it shows up in both browser windows because they were both connected to the same WebSocket endpoint, which in turn is being hosted by ASP.NET Core, compiled to WebAssembly, running on Wasmtime there. All right, so very good. So that is how we can take some ASP.NET Core features that you already know and love and compile them using this WASI SDK and have them run in a standard WASI environment. But to be honest with you, the point of doing this is not really just to build the same kind of applications with the same architectures as you would have done in the past. Because if that's really what you want to do, then you can just run your code normally on bare metal. You don't really need WebAssembly. The point of working to a spec like WASI is to explore newer application architectures and to build different kinds of cloud-native microservices. So I'm going to give you some examples of that in a little bit. But before we get to that, I just want to give you a really bizarre example of something that you absolutely should not do. But I just want to show it to you because it's so weird and mind-bending that it's even possible. All right, so just bear with me for a moment while I explain what's going on here. So I've got another ASP.NET Core application, which is going to render some HTML. In fact, it's going to be a classic server-rendered to-do list type application. So it's got a form where you can add items and remove items and so on. And the important thing to understand here is that this is not Blazor, and it's not any JavaScript-based framework. It's purely server-rendered, all right? But it's still going to be interactive. So where can we run a server-rendered application like this? Can we, for example, run it on GitHub Pages? Well, classically, the answer to that would be no way. You, of course, cannot run it on GitHub Pages because that just serves static files, so you can't do server rendering. Well, let's see about that, shall we? I'm going to go back to my browser now, and I'm going to go to this URL, which, as you can see, very much is on GitHub Pages. And it's a real URL. You can go to it yourself if you want to. And when I do go there, it says it's starting up ASP.NET Core Server. And when it has started it up, what's going to happen? Well, it's going to show up the actual server-rendered application that I just showed you the source code to. So we've got our to-do list example, and we can add stuff, do stuff, add that onto the list there. I can have multiple browser tabs, both connected to that. And you can see they're sharing the same data. I can go and I can view the same data as a JSON web service, okay? And it's all working as a server-ended application. But in case you missed it, the magic trick that's going on here is that this is actually running inside the browser. So what on earth and how is that possible? Well, as I've just shown you, we've got a way of compiling an ASP.NET Core Server application to a single standard WASI-compliant Wasm file. And one thing that's fairly famous for being able to run WebAssembly is, of course, browsers. So that technically means we can now run ASP.NET Core Server inside the browser. And that's what we're doing here. And it's a terrible idea. You should absolutely not do it. It's an awful way of delivering your site, but it is technically possible. And in case you were not clear on exactly how that worked, let me just quickly illustrate it and how tabs were sharing state. So the ASP.NET Core application was actually running inside a service worker there, which means that when any tab tried to make an HTTP request to the server, it didn't actually go to the server. It was intercepted by the service worker, which ran it through the ASP.NET Core pipeline and produced a response completely inside the browser. And if there was a second tab, then that would also have been talking to the same instance inside a service worker, which is how they were sharing state. Okay, so that's not something you should really do. It's just a fun trick, but I think it does illustrate something about the extreme flexibility that this gives us to run any kind of .NET application, or at least ASP.NET Core applications and many other kinds, anywhere that WebAssembly can run, which includes a browser, but that's probably not really what you want to do. All right, so if that's not what you want to do, what actually do you want to do? Well, I'll give you some examples. There's a lot of industry momentum going on at the moment with many different open source projects and startups trying to build things around the WASI spec. And an example of that includes Suborbital. That is a startup that's got a number of products designed for WASI. And I'm going to show you an example of one of those in a minute. So we'll ignore that for now. There's also Wasm Cloud, which is an open source project that is trying to replicate many of the things that Kubernetes does. But instead of building a cluster out of Docker containers, Wasm Cloud lets you build a cluster out of WASI-compliant modules, which can all talk to each other across certain channels that you define. So it's much more lightweight. There's also Envoy, which is the reverse proxy system that people very commonly use inside service mesh architectures. And that's got an extensibility model based on WebAssembly. So you can actually run WebAssembly inside, so you can actually run ASP.NET Core inside Envoy now, if you want to. Okay, there's Fermion. That's another startup, which I've been having some conversations with recently. They've got some interesting new ways of running WASI modules, but I can't technically give you too many details about that just now, so we'll just move on past that. There's Lunatic, and they are building something that's a bit like the Erlang Beam VM. So this is an actor model system, and the idea is that instead of deploying just a single Wasm module to your server, you would deploy many Wasm modules, and then instead of just running one instance of each, you might run tens or hundreds of thousands of instances of each of them in a huge cloud of actors. And the idea of that is to give you some extreme scalability and reliability. So that's interesting. And of course, let's not forget our very own Azure, which now supports WASI workloads as an experimental part of the Azure Kubernetes service. So that's something you might want to try out. Okay, now the last demo that I'm going to give you is related to Suborbital, whose logo you see there. And they have got a WASI runner called SAT. And the idea for SAT is that it's meant to be as small, lightweight, and fast as it possibly can be, so that you could run your WASI-compliant applications and just anywhere, for example, on low-powered IoT devices, on toys, on printers, whatever you want to. And so I want to show you an example of running an ASP.NET Core application on the SAT runner. So back in Visual Studio here, I've got this thing here, which is an ASP.NET Core application, and it's going to do something that's actually quite simple. So this is not a visually spectacular demo, okay? It's fairly basic stuff, but I think it's important to see this because it really covers the end-to-end situation. We've got an ASP.NET Core application made out of these normal endpoints here, and we're going to compile it to WebAssembly, and we're going to run it on a third-party runner, which is going to supply some additional services. So SAT, as well as running your WASI code, also provides facilities like key value storage, which could be backed by Redis, or GraphQL querying, and various other services like that you can compose your application from. And in this case, I'm going to use the key value store that they provide. Okay, so I just want to show that we can get and set values in that. So let's start this running now. So that's going to come up. And when that shows up, you'll see this time it's not running inside Wasmtime. It's running inside SAT there. And I want to make some requests into it. So I'm going to use curl. Okay, so I'm going to say, okay, let's store something called event name, and we'll have the value build. Okay, right, so I send that, and then we get back a 200 okay. And then if I do the same request, but with just a key and not a value, then you'll see the value comes back. All right, so like I said, not visually spectacular, but it does really show an end-to-end picture of putting all these technologies together. All right, so that brings us up to the end of the time that we've got. So I would say, please go and try this out yourself. You can go to the URL that I've got on the screen there, and that will take you to a GitHub repo that contains the actual SDK that I've been using. And it also has some other instructions for how to get started with it. Now, I'll remind you one more time that this is just experimental. We have not committed to shipping anything specific here, but we do see a lot of industry momentum and excitement about it. So we really want to know what your use cases would be for this sort of thing and how your experience goes when you try using it with various different third-party WASI-based technologies. So give it a go and let us know what you think. So that's all from me. Thank you very much for watching this, and I hope you have a really good rest of the event. Goodbye.